Okay. These are your quadratic formula notes. So what we'll be doing here to get started, just completing the do now, where I want you to find all the zeros of the following functions. It says use any two methods, any of the two methods, whatever you want. Remember, why don't you just go ahead and try both of those on your own. Pause the video, give it a try. Okay, welcome back. So remember, whenever you're solving for zeros, you should always start by factoring out a GCF if possible. So I notice each of these is divisible by 4, and there's also an x squared term in each. So there's an x in each, and x squared is the lowest exponent, so that's why we pull out an x squared. So 4 divided by 4 is 1. X to the 4th divided by x squared is x squared, because 4 minus 2 is 2. 16 divided by 4 is 4. X to the 3rd divided by x squared. Remember, subtract exponents through division, so it's just x to the 4th. Next, negative 84 divided by 4 is negative 21. X squared divided by x squared is just 1. From there, I notice we have a trinomial with an x squared term. So let's see if we can factor this out into something that multiplies to c and adds to b, or multiplies to negative 21, adds to negative 4. So the numbers that multiply to 21 would be 1 and 21, 3 and 7. So a negative 7 and positive 3 would multiply to negative 21, add to negative 4. Now we factor as much as we can, so we just set each factor equal to 0 to solve for our zeros, our roots. So divide both sides by 4 here to get x squared equals 0. Take the square root, you get x equals 0, that's 1. Here you can add 7 to both sides, so you get x equals 7. And then you can also subtract 3 from both sides in this one to get x equals negative 3. So we got 3 roots. Over here, 4x squared plus 17x minus 15. No GCF, since one term doesn't have any variables, and none of them are divisible by anything. Or the same thing, 17 is a prime number. So what we could do is we could look to factor this out. So remember, you multiply a and c, so a times c is negative 60. And then you look for factors of AC of negative 60. That'll add to 17. Or actually subtract. Since you got a negative here, they're going to have to multiply to a negative, so one has to be positive, one has to be negative, and they got to add to 17. So factors of 60. So we have 1 and 60, we have 2 and 30, we have 3 and 20, ding, ding, ding. 3 and 20, that feels like 17, so if we have a positive 20 and a negative 3, that's going to add to 17. Okay. So what we do to solve these then is you set up a box. We have 4x squared. Let me get a little closer. We have 4x squared. We have that negative 15, and then we have those two factors. We have a positive 20x and a negative 3x. And then you factor out on both sides, or you look for the GCF of every column and every row, column, row. So 4x squared and 20x would be 4 for 4 and 20, and then just an x. Here, 4 and 3, no common factor. X squared and x, you can pull out an x. 20 and negative 15, both divisible by 5, and then you just have that x, which there's no x there, so you can't pull any out. And then negative 3 and negative 15 both have 3. Could be negative, could be positive. So from here, we've got 4x and 3. We've got x and 5, and these need to multiply out to something like to this. So 4x times x, that's going to give me my 4x squared. 4x times 5 will give me 20, and 3 times x gives me 3x, so we want a positive 20x and negative 3x, because that'll get us to 17. Negative 3 times 5 is negative 15. From there, it's factored. Now you just set each factor equal to 0. Solve for x. So we add 3 to both sides here to get 4x equals 3. Divide by 4, and you get x equals 3/4. Here, you just subtract 5 from both sides to get x alone. You have x is negative 5. There we go. So this is using that table method that you would have learned previously. Okay, another way to find zeros or roots is the quadratic formula. So, the quadratic formula, you may recall, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, to use this, the equation must always be set equal to 0. So in some instances, you can factor, you can use that table method that we looked earlier. In every instance, you can use the quadratic formula to find zeros. So, as we look at this problem here, our goal is to find all the zeros of this function. So let's use the quadratic formula. So there it is up there. So we have x is equal to negative b. So notice a, your a value, this is for, we'll say f of x equals ax squared plus bx plus c. So this is for a always goes with x squared, b with x, and c is the constant. So here our a is 4, our b is 8, and our c is not 7 because it has to be set equal to 0. So we got to subtract 4 from both sides to get 3. Now, it's all lined up correctly. A is 4, B is 8, C is 3, so you just plug them in. So B is 8, so we have x equals negative 8 plus or minus the square root of 8 squared minus 4 times A, which is 4, times C, which is 3, all over 2 times A, which is 4. Now you simplify. So let's simplify under the square root first. 8 squared is 64. 4 times 4 is 16, times 3 is 48, so we have minus 48, all over 8. 64 minus 48 is 16, all over 8. Square root of 16 is 4, since 4 times 4 is 16. And there we go. We're getting closer. So, whoa, sorry, I lost you. Next we have negative 8 divided by 8 and 4 divided by 8. So negative 8 divided by 8 is negative 1. 4 divided by 8 is 1/2. So we have negative 1 plus 1/2, which would be negative 1/2. Negative 1 minus 1/2, which would be negative 3/2. Quadratic formula, got our solutions. And you should be able to plug those back into the original, and it should all equal out. Okay. All right. We've got 4 more problems here to get some extra practice in. I'll go through one more with you, but if you want to pause the video, write them all down, do them all on your own, and then check, cool with me too. You can probably just skip to the end of the video and all the answers will be kind of shown there. But let's start here. So make sure it's equal to 0. Sorry about that. Make sure it is set equal to 0 first. So let's add 10 to both sides. So when we add 10 to both sides, we get 0 on the right. And here we've got negative 3. Now, it's all set up evenly, nicely for us. So, let's use the quadratic formula. So we have x is equal to, or I guess in this case the variable is m. So we have m is equal to negative b, so 7. Because negative is positive, plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is negative 3, all over 2a. Simplify what's under the square root. So we have 49. 4 times 2 is 8, times negative 3 is negative 24. Minusing that, so it's same thing as a plus 24. Yes, 24. All over 4. So we have 7 plus or minus the square root of 49 plus 24. So 49 plus 20 is 69, plus 4 is 73, all over 4. 73, do any perfect squares go into 73? 9 doesn't, 4 doesn't, 16 doesn't, 25 doesn't, 36. Nope. So we're all done. There's no way we can simplify that any further. You can write it as the plus and minus separate, but you can leave it like this too. That's fine with me. Okay. Next problem. Y equals negative 3x squared plus 7x minus 4. So y equals just the same thing as saying like f of x equals. So this just means we have our function. So let's set the function equal to 0. And now whatever makes this 0 will give us our roots. So we use the quadratic formula to do that. So we have x here, so we have x equals negative b, so negative 7, plus or minus the square root of b squared, so 7 squared, minus 4 times a, which is negative 3, times c, which is negative 4, all over 2 times a, which is negative 3. Simplify that down. 7 squared is 49. Negative 4 times negative 3 is a positive 12. Times negative 4 would give us a negative 48. All over 2 times negative 3 is negative 6. Okay. 49 minus 48, that's an easy one, that's just 1. Square root of 1 is also just 1. So we have x is equal to negative 7 plus 1 over 6, and negative 7 minus 1 over 6. Negative 7 plus 1 is negative 6. Negative 6 over 6 is negative 1. And here, negative 7 minus 1 is negative 8 over 6, which you can divide those both by 2 to get 4 over 3. So we have 4 over 3, negative 1. Sorry, not a lot of space for you there. Okay. 2 more. X squared plus 2x minus 1 equals 2. Gotta set it equal to 0, so let's subtract 2 from both sides. X squared plus 2x minus 3 equals 0. Okay, so we can use the quadratic formula, although sometimes you don't need to. Let's see if we can factor this. Goes and multiplies to negative 3, adds to positive 2. Sounds like positive 3 and negative 1. So, set each of those equal to 0. X equals negative 3 and x equals 1. Boom. Didn't even need the quadratic formula. Last one. Everything's got to be set equal to 0. Let's move everything over to this 9n squared. So let's subtract 7n, subtract 4 from both sides. So we have 9n squared minus 7n minus 4 equals 0. Quadratic formula time, let's see. You might be able to factor that out, but I feel more comfortable using the quadratic formula. X equals negative b plus or minus the square root of b squared, which is this time is negative 7 squared, minus 4 times 9 times negative 4. I'm just all over 2 times 9. I'm noticing that in this first problem, it didn't end up making any actual mistakes, but b was actually negative 7 here. I should have written that as negative 7. Sorry about that. But continuing, simplify the problem. So we have square root of 49. 4 times 9 is 36, or negative 36 rather. Times negative 4 is going to give me positive 36 times 4. Whew. So that's 144. That's a nice number. All over 18. And let's keep it going. Let's fly up here. 7 plus or minus 49 plus 44 is 193. Yes, 193 over 18. So can we simplify the square root of 193? I'm not sure. So you'd have to just divide this number by different multiples or by different perfect squares, see if any factor out. Don't think there are any. So we could call it there. And that's it. So I'll zoom out for you here in case you just decided to do them all. Those are your answers. Quadratic formula, and just another way to solve for roots, solve for zeros. Now this video is a little fast, so go back if you need to rewatch some things, hear me re-explain, make it half speed, whatever you gotta do. See ya.